All right, we're going to take the concept of medians and centroids and altitudes and the orthocenter and apply them to our coordinate geometry. So we can use our algebra to find the centroid or the orthocenter. So centroid is the true middle. All these centers that we're finding are different types of centers of the triangle, but the centroid is the truest since it's the balance point of the triangle. And usually when we talk about the true middle of things, we're talking about the average. So if you actually find the average x value and average y value of your three vertices, that will be the centroid. So if I've got a triangle with these vertices, I can average my x values. So take 2 plus 8 plus negative 3 and divide it by 3 since I have 3 of them. And that'll give me my x value of my centroid. So I'd get 2 plus 8, which is 10, minus 3 is 7, divided by 3 is 7/3. Or if you wanted to think of it as 2 and 1/3, you could. And then we do the same for the y's. Negative 5 plus negative 1 plus negative 10 divided by 3. So that's negative 16/3. And to help us graph that, that's actually going to be negative 5 and 1/3. So here I've got the points graphed out. If I place my centroid, which we said is at 2 1/3, so I'm going to go over 2 1/3 and then down 5 1/3. That'd be right about there. So let's just put our lines in, kind of see how this centroid would look in the actual triangle. Okay, so that means if I had this triangle cut out, this point right here would be the point that I could balance it on. That's my centroid. So centroid is just the average. It's a lot like, it's the same as kind of our midpoint concept. Midpoint, you average the x's, average the y's, only now we've got 3 of each to average. The orthocenter, which requires the altitudes, is a little bit more advanced algebra. Because what we're going to have to do is, we're going to have to find the equation of lines that go through a given vertice and are perpendicular to the line that connects the opposite two vertices. So let's copy our picture over here. Just so we can kind of see what's going on. I'm going to take my centroid out of there. So what I'm looking for is a line that goes through this point and is perpendicular to this opposite side. In order to do that, I'm going to need to know the slope of the opposite side so that I can take the perpendicular slope and this point and use my point slope form to come up with the equation. So first I'm going to find the equation of this, the altitude that comes through this vertex first, which means I need the slope of the line that goes through these two. So to find slope, we subtract our y's, so negative 10 minus negative 1 would be negative 9. And then we take negative 3 minus 8, which is negative 11. So my slope would be 9/11. So my perpendicular slope is going to be negative 11/9. So that's my slope that I'm using. This is my x1, y1. So the equation of my line is going to be y minus y1, which makes it plus 5, equals my perpendicular slope times x minus x1. And then we can distribute Gives me plus 22/9. And then subtract the 5 over. But since we're going to be subtracting from 9ths, I want to know how many 9ths I have. 5 whole things is 5 times 9, or 45/9 is what I'm really subtracting when I subtract 5. So that means I've got this equation, y equals negative 11/9 x minus 23/9. That's the equation of one altitude. We could find all 3 equations of our altitudes, but really we only need 2, because we know that all 3 are going to meet in the same point. So if we find where just 2 meet, that'll still be our orthocenter. Okay, if I just quickly drew these in. Okay, if I have my altitude from here, let's say it's something like that, and my altitude from here, which would be kind of over here. Okay, if those 2 meet here, I know the last one's also going to meet in that same spot. So really I only need 2 equations in order to find my orthocenter. So we'll just do one more. So I'm going to get rid of my picture at this point. So now let's find the equation of the one that goes through this point, which means I need the slope that's going on between these two. So my slope, I'm going to take negative 10 minus negative 5, which turns into plus, which gives me negative 5 over negative 3 minus 2, which is negative 5. So I have a slope of 1. Perpendicular slope is the negative reciprocal, so it'd be negative 1. I've got y minus, now this is my y1. So minus negative 1 is plus 1 equals my perpendicular slope times x minus 8. So I get y plus 1 equals negative x plus 8. Subtract the 1 over, and I get y equals negative x plus 7. So I've got these 2 equations here, and I need to find out where they intersect. So basically I'm going to be solving the system, these 2 systems, or the system of equations. So the system of equations would be y equals negative x plus 7, that's one equation. And then I've got the other equation. So if you remember your ways to solve systems, there's 2 main ways. There's the substitution method, which means I would solve for a variable and plug what that variable equals in for the other variable in the other equation. So in this case, I would take negative x plus 7 and plug it in for the y in my other equation. Or you can do the linear combination method, which is you'd have to multiply one of these equations by a number that'll make one of its variables the exact opposite of the other. So I could multiply my top equation by negative 1, because then I'd have negative y and positive y, and then you add the equations up and they cancel out. It's just easier to do substitution when you have them solved for y already, though. So I'm just going to substitute this in for the y down here. Okay, now right here, I know you guys don't like fractions, so what we're going to do to get rid of these fractions is we're just going to multiply both sides of this by 9, because that'll get rid of my denominator. So I'm going to have negative 9x plus 63 equals negative 11x minus 23. And now I don't have fractions, it's easier to solve the equation. So I'm going to add the 11 over, which will give me 2x. I'm going to subtract the 63, which will give me negative 40. So x equals negative 20. Or actually, no, that doesn't give me negative 40. So I'm subtracting, so that'd be negative 86. So that means x is negative 43. So that's our x. To find our y, I just plug it plug our x value into either equation. This one's the easier one. So if I put x in place, or negative 43 in place of x, I get 43 plus 7, which is 50. So my orthocenter is going to be at the point negative 43 comma 50. That's the process for using coordinate geometry to find your orthocenter.